So, good morning, friends. Today we are going to discuss about actuators. So, these actuators generally they are used in hydraulic and pneumatic circuits, and if they are used in hydraulic circuits, uh, naturally, they are called as hydraulic actuators, and if they are used in pneumatic circuits, they are called as pneumatic actuators. So now today we are going to discuss about the control of actuators, so which also indicates the operation of actuators in hydraulic and pneumatic systems. So this hydraulic actuators or pneumatic actuators, so they are called by different names. So hydraulic actuator, it's also called as a hydraulic motor or hydraulic cylinder. Also, they're called as oil actuators, oil cylinders, and oil motors. And similarly, pneumatic actuators, they are referred to as pneumatic cylinders, and also they're called as air actuators, air cylinders, pneumatic motors, and air motors. So these are the different names given to these items. Now, basically, in general, they are referred to as cylinders. These cylinders, they are very essential for operating. They are used for operating the tools of machines. Also, they are used for rotating the spindles of machines, and they are also used for moving loads in upward and downward direction. And finally, they are also used for doing press working operations. So these are the main activities of actuators, also called as cylinders, and these cylinders, they are very essential for operating hydraulic circuits, and also for operating pneumatic circuits, and finally for operating hydro pneumatic circuits or hydro pneumatic systems. Now, secondly, these cylinders are classified into two categories. The first one called as a single acting cylinder, and the second one referred to as a double acting cylinder. Now, at this point, we are going to discuss about the control of operation of a single acting cylinder. Now, friends, as the name itself implies, fluid will be acting only on one side of the cylinder. That is, it will be acting only on left hand side of the piston as shown in the figure. So therefore, they are called as single acting cylinders. Now, as shown in the figure, a piston is arranged inside the cylinder, and that is fitted to a piston rod. And finally, this piston rod is connected to the tool of the machine. So therefore, during the operation of the system, the piston will be continuously moving in forward and backward directions. So therefore, this arrangement is used for operating the tool of the machine in forward and backward directions. So this way, the cylinders can be used for moving the tools of machines in to and fro directions. And secondly, sometimes the piston is directly connected, fitted to a connecting rod mechanism. So using this mechanism, this cylinder can be also used for rotating the spindle of the machine. That means the connecting rod will be converting reciprocating motion of the piston into rotary motion of the spindle. So therefore, with the help of connecting rod mechanism, these cylinders can be also used for rotating spindles, for rotating machine spindles or spindles of machines in clockwise direction. So friends, basically these cylinders can be used for operating, for moving the tools in to and fro directions. And also with the help of connecting rod mechanism, these cylinders can be also used for rotating the spindles of machines in clockwise direction. So friends, these are the major applications of these cylinders. And now, as shown in the figure, the cylinder is arranged in horizontal position, and sometimes the cylinders are also arranged in vertical positions. Now, in the vertical position, if the piston rod is coming above the piston, so it can be used for moving loads in upward and downward direction. And if the piston rod is arranged, below the piston, then it can be used, then the cylinder can be used for performing pressing operations. So friends, generally hydraulic cylinders are used for operating tools and horizontal cylinders are used for operating tools and spindles of machines. The vertical cylinders can be used for doing press working operations, and also they can be used, vertical cylinders can be used for moving loads in upward and downward directions. So these are the, various types of cylinders, arrangements of cylinders used for performing different operations. Now, you can see the as informed in the beginning. So this is the arrangement of a single acting cylinder. So fluid is entering and leaving the cylinder from the left hand side of the piston. So it is acting only on the left hand side of the piston. So therefore it is called as a single acting cylinder. Now, as mentioned earlier, a piston is, we can see the arrangement of the piston that is fitted to the piston rod, which is also shown in the figure. And finally, a return spring is arranged in between the right hand side of the piston and right end of the cylinder. That means one end of the spring is fitted to the piston, right hand side of the piston, and the other end of the spring is fitted to the right end of the cylinder. So therefore, here in the case of single acting cylinder, fluid pressure is used for moving the piston in forward direction, and spring pressure will be used for moving the piston in reverse direction. So friends, this is the general arrangement of a single acting cylinder. Now, secondly, a passage is made on the left side, left hand side of the piston for supplying and receiving fluid that is coming out of the cylinder. So this is called as a cylinder port. So through this cylinder port, fluid will be entering the cylinder for performing forward stroke of the piston. And secondly, in the next phase, the fluid will be leaving the cylinder for performing the return stroke of the piston. So one port is sufficient on the left-hand side of the piston for supplying fluid into the cylinder, and also for supplying fluid into the cylinder during the forward stroke of the piston, and also for receiving fluid from the cylinder during the return stroke of the piston. So friends, fluid pressure is used as a whole in the case of a single acting cylinder. Fluid pressure will be used for moving the piston in forward direction, and spring pressure is used for moving the piston in reverse direction. So this is called as a cycle, one cycle of operation. So therefore, these cycles of operation will continue as long as the circuit is in working condition. So friends, this is about the arrangement and this is about the various parts and arrangement of a single acting cylinder. Now, secondly, here we can see the arrangement of a valve that is meant for controlling the fluid that is entering the cylinder, controlling the direction of fluid that is entering the cylinder, and also this valve will be controlling the direction of fluid which is leaving the cylinder. So controlling the direction of fluid which is entering and leaving the cylinder, that is very, very important. So this valve is used for that purpose. So that's why it is referred to as a direction control valve. So any valve which is used for controlling the direction of fluid that is entering and leaving the cylinder, that's why it is referred to as a direction control valve. Now friends, an element that is called as a plunger is arranged inside the body of the valve, and this plunger will be moving in to and fro directions. And finally, the bottom of the plunger is fitted to a spring that is arranged inside the body of the valve, and top of the plunger is fitted to a push button. So therefore, it is called as a push button DC valve. So friends, here this push button is used for moving the plunger in downward direction, and spring pressure will be used for moving the plunger in upward direction. So this is about the arrangement of a DC valve used for operating, used for controlling the operation of a single acting cylinder. And secondly, we can see the passages made inside the body of the DC valve. So they are referred to as valve ports, and this is called as inlet port of the DC valve. So this is connected to the pipeline coming from the hydraulic pump in the case of a hydraulic system, and it is connected to the pipeline which is coming from the compressor in the case of pneumatic system. So whatever may be the case, the fluid coming from the supply source will be entering the valve through this particular port. So therefore, it is referred to as inlet port of the DC valve. And friends, we can see one more valve which is called as outlet of the DC valve. So this is used for sending the fluid into the cylinder and during the forward stroke of the piston, and also for receiving the fluid coming out of the cylinder during the return stroke of the piston. So as a whole, it is used for sending. Basically, it is used for sending fluid into the cylinder. That's why it is called as outlet of the DC valve. So this outlet port, therefore the outlet port is fitted to the pipeline that is entering the port of the cylinder. So therefore this is the second passage. This is referred to as inlet port of the DC valve, and this is referred to as outlet port of the DC valve. And finally, we can see one more port passage is provided in this particular region, that is called as exhaust port of the DC valve. So friends, as the name itself implies, this is connected to the pipeline, that is going back into the oil reservoir in the case of hydraulic circuit. And in the case of pneumatic circuit, it is connected to the pipeline that is entering the, atmosphere. So whatever may be the case, in both the cases, this port is used for discharging the fluid that is coming out of the system. So that's why it is called as exhaust port of the DC. So friends, this valve is having three, ports. One inlet port of the DC valve, and this is the outlet port of the valve, and this is the exhaust port of the DC valve. So totally, it is having three ports: one inlet, one outlet, and one exhaust. So totally, it is having three ports. So therefore, it is referred to as a three-way DC valve. So friends, these three-way valves are very, very essential, whether it is a hydraulic or a pneumatic system. Three-way valves are very, very essential for operating or for controlling a single acting cylinder. So this is the diagram which indicates the direct control of a single acting cylinder. So this is the figure which indicates the DC valve, which indicates the arrangement of a DC valve, which is controlling the operation of a single acting cylinder. Now, friends, by pressing the push button will be used for moving the plunger in downward direction, as I've already told you, and the spring pressure will be used for moving the plunger in upward direction. Now, when the plunger moves in downward direction, the valve will be coming to first position. That means inlet will be coming in contact with outlet, and the exhaust will be coming to closed position. So therefore, the fluid which is coming from the supply source will be flowing from inlet to outlet of the DC valve, and finally it will be entering the cylinder that is used for performing the forward stroke of the piston. Now, in the second phase of operation, the spring pressure will be moving the plunger in upward direction. So therefore, when the plunger moves in upward direction, it will be coming to second position. And in this position, outlet will be in contact with the exhaust, and inlet will be coming to closed position. That means, friends, the supply of fluid is cut off into the cylinder. So therefore, by virtue of this spring pressure, the piston begins to move in reverse direction. So fluid will be coming out of the cylinder. It will be entering the valve at the outlet. The outlet is in contact with the exhaust. So therefore, the fluid will be discharged either into the atmosphere in the case of pneumatic circuit, or into the oil reservoir in the case of hydraulic circuit. So friends, the first position in any case, in any situation, first position of DC valve is used for performing the forward stroke of the piston. And second position of the DC valve is used for performing the return stroke of the piston. So valve positions are very, very important for moving the pistons arranged inside the cylinder. So if valve comes to first position, then the piston moves in forward direction. And if valve comes to second position, automatically the piston moves in reverse direction. So as already informed, friends, If the valve is in first position, inlet will be in contact with outlet, so therefore fluid will be entering the cylinder. That is used for moving piston in forward direction. And when the valve comes to second position, outlet comes in contact with the exhaust, so supply is cut off into the cylinder, so therefore the piston moves in reverse direction. So friends, in any situation, first position of the DC valve is used for performing forward stroke of the piston, and second position of the valve will be used for performing the return stroke of the piston. So these valves will be also, operating automatically. So all these operations will be taking place automatically, so far as the circuit is in working condition. And finally, I would like to repeat about the positions of the valve. The first position, inlet will be in contact with outlet and exhaust will remain in closed position. And in the second position of the valve, outlet will be in contact with the exhaust and inlet will be coming to closed position. So friends, this is very, essential for moving piston in to and fro directions. So first position of the valve for forward stroke of the piston. Second position of the valve for performing return stroke of the piston. Secondly, when the plunger moves in downward direction, valve will be coming to first position. When the plunger moves in upward direction, valve will be coming to second position. So friends, all these operations will be taking place automatically. It's a very interesting arrangement. So now this DC valve, a small DC valve, is controlling the operation or actuation of a big cylinder. So therefore it is called as direct control of single acting cylinder. So friends, this is the arrangement to be made for performing or having direct control of a single acting cylinder used either in hydraulic circuit or hydraulic system or in pneumatic circuit or a pneumatic system. Friends, if the cylinder is used in hydraulic circuit, which is called as hydraulic cylinder. If it is used in pneumatic circuit, it is called as air cylinder. Similarly, if this valve is used in hydraulic circuit, it is called as a hydraulic DC valve. And the same thing, if it is used in a pneumatic circuit, it is called as a pneumatic DC valve. So friends, these valves, whether it is the DC valve or whether it is a cylinder, these items are used in hydraulic circuits, not only in hydraulic circuits, but these items can be used even for operating pneumatic circuits. And finally, in the case of hydraulic circuit, oil will be flowing in these, pipelines. In the case of hydraulic circuit, oil will be flowing through all these pipelines: inlet pipeline, outlet pipeline, and exhaust pipeline. And in the case of pneumatic circuit, naturally compressed air will be flowing through these pipelines. So friends, this is the arrangement of controlling cylinders, which can be used either for operating hydraulic circuits or for operating pneumatic circuits. So we have talked about the, control of a single acting cylinder. So therefore, it is called as direct control. This valve is directly controlling the operation of the cylinder. So simply, it is called as direct control of a single acting cylinder. So friends, this is about the construction and working of this particular arrangement, so called as control of cylinder. So friends, now it is, we have talked about direct control of a single acting cylinder. Now we are going to, talk about the control of a double acting cylinder. So we can see the arrangement of a double acting cylinder. As the name itself implies, the fluid will be acting on both the sides of the piston. So it will be entering and leaving from both the sides of the piston. So therefore, it is called as a double acting cylinder. So in other words, if the fluid is entering from the left-hand side of the piston, it will be leaving from the right-hand side of the piston. That is used for performing forward stroke of the piston. And if the fluid is entering from the right-hand side of the piston, so the fluid will be leaving from the left-hand side of the piston. That is used for performing the return stroke of the piston. So if a fluid is acting only on one side of the piston, that is called as a single acting cylinder. And in this case, a fluid is acting on both the sides of the piston. Therefore, it is referred to as a double acting cylinder. So friends, fluid pressure is used not only for performing forward stroke of the piston, but also it is used for performing the return stroke of the piston. So that's why it is called as a double acting cylinder. So it will be entering and leaving from both the sides of the piston. It will be entering from one side of the piston and it will be leaving from another side of the piston. So as a whole, the fluid will be acting on both the sides of the piston. So therefore, it is called as a double acting cylinder. And friends, we need two ports in the case of a single acting cylinder. One port is sufficient for a single acting cylinder. But whereas here we have to provide two ports for a double acting cylinder. First port will be coming on the left hand side of the piston, first cylinder port. And the second port will be coming on the right hand side of the piston. So that is called as the second port of the cylinder. So if fluid is entering from first port of the cylinder, it will be leaving from the second port of the cylinder. That is used for forward stroke of the piston. And similarly, if fluid is entering from second port of the cylinder, it will be leaving from first port of the cylinder. That is used for performing the return stroke of the piston. So friends, this is the basic difference between a single acting cylinder and a double acting cylinder. So in the case of a single acting cylinder, fluid pressure will be moving the piston in forward direction and spring pressure will be moving the piston in reverse direction. But whereas in the case of a double acting cylinder, fluid pressure will be moving the piston in forward direction, as well as it will be also the same fluid pressure will be also moving the piston in reverse direction. So for both the operations here, we are using fluid pressure for performing both the operations of the piston. So it is acting, the fluid is acting on both the sides of the cylinder or both the sides of the piston. So therefore, it is called as a double acting cylinder. And friends, naturally this first port has to be connected to the DC valve, just like the arrangement of a single acting cylinder. Here also the first port of the cylinder is fitted to the DC valve, and the second port of the cylinder, that is also fitted to the DC valve. So friends, these are the arrangements to be made for operating a double acting cylinder. So supply of fluid from this pipeline will be moving the piston in forward direction, and this pipeline will be sending back the fluid into the DC valve. And in the second phase of operation, this pipeline will be supplying fluid from right hand side of the piston, and this pipeline will be receiving fluid coming out of the left hand side of the piston. So friends, first operation for doing the forward stroke of the piston, and second operation for performing the return stroke of the piston. So friends, we can see the arrangement of the piston, just like a single acting cylinder. We can see the arrangement of the piston that is fitted to a piston rod. So piston rod can be fitted to the tool of the machine. So therefore, the tool can be made to move in to and fro directions. And just like single acting cylinder, the piston can be directly, it can be fitted to a connecting rod mechanism. So in such a situation, in that case, this cylinder can be also used for rotating the spindles of machines. So friends, just like single acting cylinders, double acting cylinders, they can be used, they are used for moving tools in to and fro directions. Also used for, rotating spindles in clockwise directions. And by arranging these cylinders in vertical direction, just like single acting cylinders, these cylinders can be also used for moving loads in upward and downward direction. Also, they can be used for performing press working operations. So friends, this is the arrangement of a double acting cylinder. One port is made on the left hand side of the piston, another port is made on the right hand side of the piston. So fluid will be acting on both the sides of the piston. So therefore, it is referred to as a double acting cylinder. Now, friends, we can see the arrangement of this valve. So this valve is used for controlling the direction of fluid which is entering the cylinder, and also the fluid that is leaving the cylinder. So therefore, it is called as a direction control valve. So in general, it is referred to as a DC valve. And a plunger is arranged inside the DC valve that is fitted to the spring, which is also arranged inside the DC valve. That means below the plunger, the DC valve. And here we can see the arrangement of a push button that is placed above the surface of the DC valve. So friends, push button is used naturally with this arrangement. Push button is used for moving the plunger in a downward direction, and spring pressure will be used for moving the plunger in upward direction. And friends, as usual, if the plunger moves in downward direction, the valve will be coming to first position. So that is used for performing the forward stroke of the piston. And if the plunger moves in upward direction, naturally the valve comes to second position. That is used for performing the return stroke of the piston. So friends, in any case, first position of the DC valve will be used for performing the forward stroke of the piston. and second position of the valve will be used for performing the return stroke of the piston. And finally, friends, here we can see the arrangement of ports. So this is the middle one. It is the inlet port connected to the pipeline coming from the supply source. And here we have the first outlet of the DC valve that is connected to the first port of the cylinder, that is connected to the pipeline which is entering the first port of the cylinder. And this is the second outlet of the DC valve fitted to the pipeline which is entering the second port of the cylinder. And here we can see two exhaust ports. The first exhaust port placed in this position for discharging fluid coming out of this system, and another exhaust port is placed below the inlet of the DC valve, that is also used for discharging the fluid that is coming out of the system. So friends, it is totally, it is having one inlet port, two outlet ports and two exhaust ports. So 1 plus 2 plus 2 is equivalent to 5. So totally it is having 5 ports, one inlet, two outlets and two exhausts. Totally it is having 5 ports. So therefore it is referred to as a 5-way DC valve. So 3-way valves are used suitable only for controlling single acting cylinders. 2-way and 3-way valves suitable only for single acting cylinders. 4-way and 5-way valves are suitable only for controlling double acting cylinders. So friends, totally it is provided, it is having 5 ports, one inlet, 2 outlets and 2 exhaust ports. So total it is having 5 ports. It is referred to as a 5-way DC valve. Now friends, if the valve is in first position, inlet will be coming in contact with the first outlet, and second outlet will be coming in contact with the second exhaust, and first exhaust will remain in closed position. So therefore, fluid will be entering from the left-hand side of the piston and it will be leaving from the right-hand side of the piston. So therefore, this is used for performing the forward stroke of the piston. And friends, similarly, the valve, if the valve comes to second position, inlet will be in contact with the second outlet, and first outlet will be in contact with the first exhaust, and second exhaust will come to closed position. So therefore, fluid will be entering. Because of this position, fluid will be entering from the right hand side of the piston and it will be leaving from the left hand side of the piston. That is used for performing the return stroke of the piston. So friends, it can be a 3-way valve or it can be a 4-way, 5-way or a 2-way valve. It can be a single acting cylinder. It can be a double acting cylinder. First position of the DC valve will be used for performing the forward stroke of the piston, and second position of the valve will be used for performing the return stroke of the piston. So this is the wonderful arrangement made for supplying fluid from one side of the cylinder and also for, at the same time for receiving fluid from other side of the cylinder. So this is used for moving the cylinder in to and fro directions. And friends, as I've already told you in the beginning, so just like a DC valve of a single acting cylinder, here also when the plunger moves, in this case also when the plunger moves in downward direction, valve will be coming to first position. for doing forward stroke of the piston. And when the plunger moves in upward direction, valve will be coming to second position. That is used for performing return stroke of the piston. So friends, I mean, this is the way of sending and receiving fluid from the double acting cylinder. So DC valves are very essential, whether it is a single acting cylinder or a double acting cylinder. It can be a hydraulic cylinder or it can be a pneumatic cylinder. So whatever may be the case, DC valves are very essential for operating, controlling single acting as well as double acting cylinders. Also, they are used for controlling, hydraulic as well as pneumatic cylinders. So friends, as I've already told you in the beginning, so if these items are used in hydraulic circuit, which is called as a hydraulic DC valve, and this will be called as a, hydraulic cylinder. The same items, if they are used in pneumatic circuits, this will be called as a pneumatic DC valve, and this item will be called as a pneumatic cylinder. So friends, using cylinders is very essential for operating, circuits, and cylinders are having several, applications. They are very essential for moving tools of machines, for rotating spindles of machines, for moving loads in upward and downward directions. By keeping these cylinders in vertical position, they can be used for moving loads in up and down directions, and also for doing press working operations. So friends, cylinders are very essential for operating hydraulic and pneumatic circuits, are referred to as actuators, and they are called as primary, most important component of hydraulic components of hydraulic and pneumatic systems. And finally, we have talked about these valves, the direction control valves, DC valves. So DC valves are very essential for controlling single acting and double acting cylinders, controlling hydraulic and pneumatic cylinders. So friends, as a whole, DC valve will be controlling the operation of this cylinder, and ultimately the cylinder will be controlling the operation of a tool or a spindle of machines. So friends, these arrangements are very important. Arrangement of cylinders are very important, and DC valves are very essential for controlling the operation of cylinders. So in this session, we have talked about direct control of single acting cylinders. Also, we have talked about direct control of double acting cylinders. So friends, before ending the session, I have given all the information, theoretical information pertaining to this valve positions, valve connections, valve elements, valve ports, and cylinder arrangements, cylinder elements, and cylinder ports, and cylinder connections, and so on and so forth. So I have given all the information pertaining to single acting cylinders and also pertaining to double acting cylinders. So I request all of you to go through these slides so that you will be getting, exact information about this control of single acting and double acting cylinders. So friends, thank you very much for watching the section.